Do you remember when I proposed my final year project last semester? All the hardship, all the hard work has been paid off. And today, I present to you my final results of final year project. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Muhammad Naikuddin bin Muhammad Zaini, a final year student from Bachelor of Information Systems, Honours in Intelligent System Engineering, with my final year project title, A Data Profiling Model to Predict Intradialytic Hypotension for Hemodialysis, under the supervision of Dr. Azin Ahmad, and this is my final presentation. Let's go!
Bismillahirrahmanirrahim, let's begin. First and foremost, for your information, my final year project title has extended a little bit. It has become a data profiling model to predict the intradialytic hypotension for hemodialysis, which is much more precise and much more concise. In this project presentations, we will cover 8 subtopics, which is first, introduction, problem statement, objective, scope, significance, summary of literature review, methodology, and last but not least is the results. These are basically the additional factual regarding the dialysis situation in Malaysia. Let's get to it. So first, introductions. So in this introduction, first we have to identify 3 important keywords throughout this whole project. So the first keyword is chronic kidney disease. So chronic kidney disease, a disease occurs when one kidney fails to operate. It is the final stage of CKD is Stage Renal Disease, which were known as ESRD. And commonly in this stage, the kidneys are not capable to function normally and will need dialysis treatment to survive. So what is dialysis treatment? There are 2 types of treatment for chronic kidney disease patients, which are hemodialysis and peritoneal dialysis. So these 2 types of dialysis treatment are used to purify the blood for dialysis patients. And last but not least is profiling in hemodialysis. There are 2 types of profiling being done to help patients for having adverse effects such as sodium profiling and ultrafiltration profiling. These are the problem statements. The problem statements can be seen in 4 indicators. First, the patient profiling itself. As mentioned, the 2 profiling that hemodialysis have, which is sodium profiling and ultrafiltration profiling, may help to reduce the adverse effect. But nevertheless, these 2 profiling are normally examined and viewed individually. Next is the data problem. The data collected from a Regression Analysis Center branch has many errors, such as null values, incomplete, and inconsistent. The data is read from a machine that specializes in reading the patient condition during the dialysis treatment by the nurse. Then data was written in an Excel form, which lead to the errors mentioned. Thus, the problem with the data leads to poor patient assessment. Next, poor patient assessment that is inaccurate may result to harmful treatment for the patient. Inaccurate blood pressure measurement, for example, might result in hypotension and hypertension that might affecting the entire dialysis treatment for the dialysis patient. And this lead to adverse effect, which as mentioned in poor patient assessment may lead to intradialytic hypotension. Intradialytic hypotension is actually the most common and severe hemodialysis complication, and it has been associated to poor long-term outcomes. Patients may experience significant acute complications such as cramp, nausea, exhaustion, shortness of breath, restlessness if they experience recurrent intradialytic hypotension during the dialysis treatment, and as well as substantial mortality risk in the medium term. Next is the objective of this project. The first objective of this project is to perform data profiling method such as structure discovery, content discovery, and relationship discovery for dialysis patient data. Next, to construct a predictive machine learning models based on data that has been profiled. And last but not least, the objective is to evaluate the proposed machine learning predictive model for predicting the adverse effect in hemodialysis patients. The scope. This project is primarily analysis on data profiling model performance on machine learning classifier. So the first scope is data sets. So hemodialysis patients that are currently active receiving treatment in a Regression Dialysis Center Setia Alam branch. The data set is gained from these patients. So next is the profiling model. The data collected is then profiled using data profiling techniques that has been studied in this research. Last but not least, the tool used. After data has gone through data profiling techniques, and various data profiling techniques and tools such as Reka, the data is then used in machine learning classifier using rapid manner and use Power BI tools to visualize the findings. Next is the significance. The first significance is to help the doctor and nurse personnel manage and monitor patients during hemodialysis session much more efficiently. Next, data profiling also may help to lower the likelihood of post-dialysis adverse effects by allowing patients to receive the treatments. And last but not least, we can see the quadruple helix sectors, which is medical and health industry, can use data profiling to improve study on patient data and can perform harmless assessment on patients. From academic perspective, we can see that the research on data profiling can be studied in more depth to bring benefits and positive impacts towards multiple industries that use data as primary sources. And last but not least, we can see the significance on the society. Holistic impacts to a society with the right techniques and methods of data profiling were applied to a society mainly revolve around data. So the holistic impacts can bring towards society if we use data profiling inside the society itself. Next is literature review. As a summary, literature review have 6 main components, which is first is chronic kidney disease, second is dialysis treatment, next is profiling in hemodialysis, next is data profiling techniques, next is machine learning, and last but not least, previous related work. The methodology. These are the research methodology flowchart. So first we begin with business understanding, which consists of preliminary study and knowledge acquisitions. Next we go to data understanding, which is data collections, and the first steps of data profiling techniques were embedded inside data understanding, which is structure discovery. Next, we move to data preparations. This inside the data preparation, we embedded another two of data profiling techniques, which is content discovery and relationship discovery. Next, we go to modeling, which is model development. Next, we go to evaluation, which is model testing and evaluation, data visualization, deployment, and documentation. These are basically the research methodology mapping. So this question will be answered inside results and findings in the last slide. And these are basically the overview of research methodology in this project. And last, finally, the results and findings. So the first questions that needs to be answered inside this project is, what is the best method to gain high quality data that can be used for modeling? So first, it is proven that data profiling techniques is the best method as it helps to produce high accuracy on predictions even with small data sets. This can be proved as a study of adverse effect predictions on hemodialysis patients using machine learning that were conducted by Zahari in 2021 shows that Naïve Bayes with 90/10 rating only produced 59.97%, while support vector machine SVM produced 61.77%. Meanwhile, in this research, as data profiling techniques were applied with the same parameter, the highest accuracy produced by Naïve Bayes is 76.92. SVM also produced a higher accuracy of 79.92% with the same splitting of 90/10. This shows that data profiling techniques gives impacts in improving the model accuracy to predict the intradialytic hypotension. Next, question number 2. What is the best machine learning prediction model? Overall, the model that produces the best accuracy is K nearest neighbors, which is KNN with 84.62% accuracy for both full data sets and strong and high moderate data sets with certified sampling technique of 90/10% split. As mentioned in Chapter 2, Section 2.4.2, and the comparisons between classification models, it mentioned that there are one disadvantage of KNN that may have skewed class distributions. This greatly represents in this research as KNN as the highest accuracy as the dataset was skewed to one classes. So in other words, imbalanced classes of datasets, however, because of data imbalance and a small amount of datasets, the biasness on the model exists, and that's why KNN can be the highest machine learning prediction model. So perhaps if this research has a lot more data collected, it will help to reduce the biasness on the model when predicting the intradialytic hypotension. And last but not least, questions number 3. How is the performance of the proposed prediction model? The performance the overall performance is good. It can be calculated that full data set and strong high data sets produce the best accuracy of 84.62% from K nearest neighbors, which reflect samplings of 90 to 10 percentage points. Even though both produce the highest accuracy, but by looking at the significant values of attributes, strong and high moderate data sets has higher values. Thus, strong and high moderate data set is considered to produce the best accuracy within this model. The error rate of this model as well is the lowest with only 15.38% at the position, and specificity is also high with 100%. That's all from me, Muhammad Zaini, your ITM. Bismillahirrahmanirrahim. Let's begin on the project demonstration of dashboard. So in the first page, we have the project page, which is the first page in Microsoft Power BI. So in this page, study descriptions, objective, and process summary were explained briefly as an introduction to this dashboard. Next, on second page, we have data description page. So in this page, raw dataset behavior was explained. So the dataset came from Setia Alam branch of Avicenna Dialysis Center. This study employed data from 5 patients, including 69 raw attributes and 135 raw instances. So this dashboard also displayed the overall number of missing values and the type of raw data. So blood pressure categories for raw dataset were classified into 3 different classes by using bar charts. So we have here not low blood pressure. We have 103 data sets that were represented by not low blood pressure, and then low blood pressure we have 27 rows, and last but not least is 5 that were identified. So VICA is used to read this raw data set. 20 attributes here is classified as nominal data type. Numeric data type has 44 attributes, and string data types has 5 attributes overall. So given the primary goal of this study was to predict the occurrence of intradialytic hypotension, it's easy to understand as based on the bar chart data, it shows that the data was imbalanced. You can see here the not low blood pressure, we have 103, and low blood pressure, that the one that we want to predict, we have 27 only. So in this study, it is predicted, it is based on research, it is shown that low blood pressure is related to intradialytic hypotension. Thus, we can see that blood pressure here is imbalanced classes. Next, we move on to structure discovery. In structure discovery, we explain in this page, structure discovery we explain and visualize. As there are 4 analyses that were performed under this discovery, each will explain individually in the dashboard before the final table constructed here. The final table here shows the combination of final 4 analyses. Domain analysis shows the total number of missing values for the raw data. For classification analysis, it shows the number of classification of blood pressure by using pie chart. For format analysis, it shows that each attributes and its format was shown in a simple table. And data property analysis, which is the study of min-max values, mean and standard deviation of the data, was shown in the final table of structure discovery finding that combined with other analysis. Next, we move on to content discovery. As for content discovery pages, so the total number of 29 attributes were discarded, while 40 attributes were used to further in the study. So the attribute that were used further in the study has 193 missing values, and as such, these missing values were cleaned and replaced with zeros. So in this page, the attributes considered is displayed in a table form with its format that were read by rapid minor, and also the number of missing values for each attribute. Among these attributes, 31 attributes are integer, and only 9 attributes are real number, which is what we call it as, or we know it as decimal number. On the other hand, attributes that were discarded were also shown in table form, alongside with the reason for us to discard the attribute. For example, date, which is not related in predicting intradialytic hypotensions. Next, we move on to relationship discovery. In relationship discovery, we can see that relationship between attributes was shown in a heat map. This heat map can be read through the table provided beside it. So the table is in this dashboard shows the correlation values between first attribute and second attributes. As we can see here, between for example, from pre-BP and dry weight, the correlation value is negative 0.06. So we can see here also, we can read it here. We can take a look at the heat map and we can read the data, the correlation matrix based on the table beside it. Next is the model performance, the last page of this dashboard. In this final page, all 4 classifiers model that were used in this research will evaluate according to accuracy, error rate, sensitivity, specificity, and precisions. Each measurement were presented in each individual cluster column charts. In each graph, each dataset were represented in x-axis was compared with the 4 classifiers in y-axis. So as we can see here, the first graph, we can show you an example. For the first graph is the graph to compare the accuracy between datasets. So the first is full dataset. We can see that the light blue is represented by K and N, the dark blue is represented by SVM, the orange is represented by Naïve Bayes, and the purple represented by linear regressions. So we can see the accuracy here. We can read the accuracy based on these bar charts, on the clustered column charts. So we can also choose to see what kind of readings that we want to see based on the data sets. So if you want to read the full data sets, accuracy, error rate, positions, and specificity and sensitivity, we can just click here. Or we can read also mid-moderate and low-moderate data sets. And we can also read the strong and the high-moderate data sets according to their accuracy, error rate, sensitivity, specificity, and precisions. That's all for this dashboard. Muhammad Zaini, thank you.